So now the step 5 demo. So basically it will create the random number between 0 to 1. So let's see, I already plot some of these numbers here. So for example, first random number came as 0.5. Now in this chart, what will happen? 0.5 will be in this box. So this particular observation will be selected. And these 0, 1, that's mean it will go here. So this observation will be selected. 0, 6, 0, again it will select this. 0, 7, 5, it will select this. In this example, it will be like this, but try to understand the intuition. What will happen? The random number when will generate, when this range is so big, lot of random numbers will fall into this error criteria, and it will pull these informations or these observations and pass it to the next tree, which is our M2. So that's a very important aspect, that okay, whatever data we are generating here, that will go, this data sets now will go to the model 2, M2. Okay, and then again this entire process will start. Okay, hopefully it's clear to everyone. Now I'll just show one more thing, that is how the final predictions is actually happening. Okay, so let's understand that also, because that's a critical part also, just for understanding part. So final, I'll not go with the red, so because it will be difficult later. So steps, all steps are done. Okay, so model is ready. Now we are going for the final prediction. Okay, let's consider we got a test data. We got a test data which is less than equal to 60k, comma, probably good. Okay, I'll just keep it as G or no, good. Okay, hopefully I can just make some space here so that I can explain it properly. So how it will work? So we will, right now we already build multiple decision tree. So decision tree 1, and then remaining whatever the error records will pass it to decision tree 2, remaining records will pass it to decision tree 3, and same way will pass it to decision tree n. Okay, and from the first tree, suppose I got the answer yes, and then suppose from the next tree I got probably the answer is no, and also I got alpha value as 0 point, because we already calculated 0.896, this was already calculated, and let's assume we got some alpha values like probably 0.650, here probably alpha value is 0.240, something like this. Okay, so what will happen, like when we'll go to the final function, so it will be like this, 0.896, and in this case the result is yes, plus 0.65, in this case result is no, plus probably 0.24, this is probably yes, plus there may be possibility something is negative, probably 0.22, whatever, 22, no, something like this. Okay, so finally what will happen, it will show you something like this, that okay, you have 1.5 yes, and probably 0.5 is no. Okay, so by this now we can say that the performance of saying yes is actually 1.5, and performance of saying no is zero point 0.5. So which one we'll select? We'll select this one. That okay. If it is less than 5, so let me just explain. So if it is less than equal to 60k and credit score is good, so what is that? Less than equal to 60k and credit code is good, then our approval chance is yes. And that's the thing will happen internally, that okay, it will say the chances of yes is 1.5 and chances of no is 0.5. So our final result is 0. Yes. Okay, that's the way the entire AdaBoost algorithm will work. I know it's little complicated, but please go through these things. I try to explain in a very simple way. Just remember this thing, it's a boosting technique. It's basically creating multiple trees. First tree is a stump. Remember this name, stump. It's an interview question. What is stump? It's basically a one level tree. You're creating the stump, then you are using the information gain technique and finding out which feature to use for that particular stump. And once you create your first tree, after that you will definitely just follow this chart. You will do the sample weights, then you will calculate the updated weight, normalized value, assign bin, and then you'll randomly generate the values and find out the rows for the next model. That way it will continue, and based on that you will get a perfect results actually. So that's why you're building so many weak learner, and from that weak learner finally we'll get the best model. Okay, see you in the next video. Thank you so much for your support. Please give me a thumbs up or subscribe my channel. um, for any kind of help, you can email me, you can just try to reach me. I'll try to help you. Thank you so much. Bye.